Since I'm about to type up your solutions anyway, I thought I'd go ahead and make a video of the solutions to the class problems from Thursday. Now, word of warning, this is going to be crap. I'm not going to bother with editing it. You're going to have ums and ahs, and there might be a cat that jumps in the picture. So this is just raw video. So first off, the questions are, does it converge or diverge? How do you know? The first one was the summation, make sure you can get this, as n goes from 1 to infinity of 1 minus cosine squared of 1 over n all over sine squared of 1 over n. Now, if this one does converge to 0, I'm not sure how else to prove that, but I do know the terms from doing this problem. I know the terms don't go to 0, so let's look at that. And this is a bit of a bear of a problem, and I apologize. You won't see this on a test, but you should see it anyway, just because it's good for your character. Pain is good? What's the expression? No pain, no gain. Yay, that works. Again. So the top one goes to 0, the bottom one goes to 0, so I can L'Hopital it. That's what I use for L'Hopital, because writing the word out is too long. Derivative of 1 is 0. I have derivative of cosine squared, so I've got a big honkin' chain rule. I have 2 times the cosine of 1 over n. The derivative of cosine of crap is negative sine crap. That's why I got rid of this negative. And then I need the derivative of 1 over n, which is negative 1 over n squared. All over, now sine squared of 1 over n, sorry, it looks kind of crappy. I'll get 2 sine of 1 over n. Derivative of sine is cosine. And the derivative of 1 over n is again negative 1 over n squared. Woohoo! These guys cancel. The 2's cancel. I copied that wrong, didn't I? Yes, I did. This was sine of 2. So this is negative. This will still be a 2 over here. Okay. Now, it's still 0 over 0, but cosine goes to 1. So I can actually get rid of those. I can say, okay, this pup goes to 1. This guy goes to 1. So this limit is the same. On top, I'm just left with sine of 1 over n. On bottom, I'm left with sine of 2 over n times 2. Now, 0 over 0. Take the derivative. Derivative of sine is cosine of 1 over n. Derivative is negative 1 over n squared. Here I have derivative of sine is cosine of 2 over n. Derivative is negative 2 over n squared. Both of these go to 1. I cancel out the n squareds. I cancel out the negative. Oop, and I lost a 2. There's still a 2 on the bottom. So this limit is 1/4, which doesn't equal 0, which means this pup diverges. Next one. Can I get a second one on this page so I don't waste too much paper? Next one, I have the summation as n goes from 1 to infinity of n over 2n to the 3/2 plus 3 over n plus 5. For this one, my p is equal to 1/2, so this diverges. That's all there is to that one. C. The summation of 1 over natural log of n plus 1. Well, since I know that 1 over n diverges, this one's going to be even worse, so this will diverge. If I want to prove it to you, which is always a good thing, I know that the natural log of n plus 1 will be less than n for large n. That's a fancy way of saying is, around 0, the first billion, it may not cross. It actually does. But eventually it'll cross and it'll stay crossed. So if not ahead of it, a big of it, less than that. So the natural log of n plus 1 is less than n, which means 1 over the natural log of n plus 1 is greater than 1 over n. This is greater than 0. Since, yeah, that's really hooky notation. 1 over n is greater than 0. Since this guy diverges, that's going to push this one to diverge in terms of the summation. So this diverges. D, let's see, we have the summation as n goes from 1 to infinity, -1 to the n minus 1 over 3 plus 5n. Do I care that that's n minus 1 instead of n? No, just means that the alternating part shifts by 1. I see that my p is equal to 1, so if it wasn't alternating, I would be upset. I'd not be upset, I don't really care. It would diverge, but because it's alternating, I know this thing converges. It's alternating, the terms are decreasing, and the terms go to 0. E. The summation as n goes from 1 to infinity of -1 to the n, 3n minus 1 over 2n plus 1. The terms go to 3/2, which ain't equal to 0. So this diverges. Done. I don't even care that it's alternating. I just know that terms don't go to 0, so I'm done. Oh, can I fit this last one in here? The summation as n goes from 1 to infinity, -1 to the n, e to the negative n. Well, the terms definitely go to 0. Notice this is the geometric series. Where my r is equal to -1 over e. And since the absolute value of r, can you see all this, is less than 1, this converges. In fact, we have a formula for figuring out what the actual sum is. Next, using the integral test, determine if the series converges or not. So the first one we have is n goes from 1 to infinity of 1 over the square root of n plus 5. Now I know this is going to diverge because my p is equal to 1/2, but the instructions were use the integral test. So I will use the integral test. The integral from 1 to infinity of this, which is n plus 5 to the 1/2 dn. Oh, -1/2. I can use the u substitution, or just, we know that the derivative of the inside is sitting here on the outside. I can just go ahead and do the power rule. So I will have n plus 5 to the positive 1/2. Dividing by 1/2 is the same as multiplying by 2. And I want to take this from 1 to infinity. Please don't show this to anybody. This is horrible notation. This becomes 2 times infinity plus 5, still really bad, minus 2 times whatever, 6 to the 1/2. This is moot, it's some finite number, but this, I've got infinity plus 5, which is infinity, to the 1/2, which is infinity. This is infinity. So this diverges. B, this is the one we did in class. I went from 2 to infinity because the natural log of 1 is 0, and that would make this undefined. So, using the integral test, I have the integral from 2 to infinity of 1 over n, natural log of n, dn. If I let my u equal natural log of n, du equals 1 over n, dn. So my integral becomes 1 over u du. That looks like a u there. And I'm not going to bother with these because I'm going to switch it back to terms of n in a second. So this becomes integral of 1 over u is the natural log of u, and we're going to take that from 2 to infinity. This is natural log of u, but my u was natural log of n. So I'm switching back to the n's, and I'm going from 2 to infinity. And if I plug that in, I have the natural log of infinity, which I can stop here because that's infinity, minus the natural log of 2. So this will also diverge. Last one. We have the summation as n goes from 1 to infinity of e to the n over 1 plus e to the 2n dn. Using the integral test, I need to integrate this thing. Integral from 1 to infinity of e to the n over 1 plus e to the n squared. I'm kind of, foreshadowing at what I'm going to do with this. If I let my u equal e to the n, the derivative is e to the n dn. So this becomes the integral star to star of 1 over 1 plus u squared du. And 1 over 1 plus u squared is arctan of u, which is e to the n. Oh, this is going to be really bad. E to the infinity minus arctan of e to the 1, which is e. Now, e to the infinity is infinity. Arctan, as the argument goes to infinity, arctan of that goes to pi over 2. And this is minus arctan of e. So I actually get a number. It's not what the summation is. Oh, why is that there? That's weird. It's not the actual summation, but since the integral converges, the summation converges. I don't know what it converges to, but that wasn't what the problem asked me to do. Next, I have a ton of power series. So, 3a. I have the summation as n goes from 1 to infinity of x to the n over 2n minus 1. These problems use the ratio test to figure out for what x's will this series converge. So I'm looking at the limit as n goes to infinity of a sub n plus 1 over a sub n. Let me just remind you of that. So I've got the limit as n goes to infinity, a sub n plus 1. Okay, so I get x to the n plus 1 over 2 times n plus 1 minus 1. Now instead of dividing and making this a big honking fraction, I'm just going to go ahead and multiply by the reciprocal of a sub n. So that gives me 2n minus 1 over x to the n. Now, whenever you have polynomial type things in this ratio test, it's the same degree on top as the bottom. The only difference is you've plugged in an n plus 1 instead of an n. You're going to have the same power. You're going to have the same degree. You will have the same coefficients. So the polynomial part will always go to 1. And what I'm left with is an extra x on top. And the ratio test says that if the limit is less than 1, it will converge. So if the absolute value of x is less than 1, it will converge. Now the ratio test says if it's equal to 1, you don't know anything. So I want to check the endpoints. Right now I've got x between 1 and negative 1. Well, if x is equal to negative 1, then my summation becomes negative 1 to the n over 2n minus 1. It's alternating. P is equal to 1, so this will converge. If I let x equal to positive 1, I get 1 to the n, which is just 1. Now my p is equal, it's not alternating, my p is equal to 1, so this will diverge. So we say the interval of convergence, write that in, is going to be from negative 1 to 1. I can include the negative 1, but I do not include the 1. We also can say the ratio of convergence is 1. Did I say ratio? Sorry, I meant radius. Because that's the radius of that interval. Kind of like the radius of a circle could be 1, but the diameter is 2. It's the same idea. You're taking half that length. Next, how about the summation as n goes from 1 to infinity? I have x to the n over n to the 4th times 4 to the n for my ratio test. I have x to the n plus 1, n plus 1 to the 4th, 4 to the n plus 1, times a sub n, the reciprocal of that. So I have n to the 4th times 4 to the n all over x to the n. Now, I wish I had a color pen. Do I have a color pen? Yes. Now again, notice the polynomial part, this n over n plus 1, both are to the 4th. So those two terms on top of each other go to 1. I have a 4 to the n on top, a 4 to the n plus 1 on bottom, which means I'm left with a 4 on the bottom. Bunk, bunk. X to the n on bottom, x to the n plus 1 on top. I'm left with an x on top. So that means I want that to be less than 1, which means x over 4 is between -1 and 1. So x is between -4 and 4. Checking my endpoints, if x is equal to -4, I get the summation as n goes from 1 to infinity of -4 to the n over n to the 4th times 4 to the n. Now 4 to the n, sorry, -4 to the n can be rewritten as -1 to the n times 4 to the n. So those cancel. I've got alternating, but I really don't care that it's alternating because n to the 4th, my p is equal to 4. It's big enough so that it converges on its own. So this converges. If x equals 4, I have 4 to the n over n to the 4th times 4 to the n. 4 to the n's cancel. I have 1 over n to the 4th. My p is equal to 4. This also converges. So my interval of convergence, my IOC, is from -4 to 4. I include both endpoints since both of them converged. Let's say our radius of convergence, ROC, because mathematicians are lazy. Well, I'm lazy. Don't like writing everything. My radius of convergence is 4. Next. Summation as n goes from 1 to infinity. -1 to the n, x to the n over the cube root of n. So I have the limit as n goes to infinity of, I'm going to ignore the -1 because I'm going to put this in the absolute value. So the absolute value of -1 to the n is just going to be 1. So all I need to worry about is the x to the n and the cube root of n. So I have x to the n plus 1 over the cube root of n plus 1 times the cube root of n over x to the n. Again, that's supposed to be cube root. Again, I have my polynomial part. The degree of the top is the same as the degree of the bottom. The coefficients are the same. So this mess will go to 1. The only thing that survives is an x on top, and that has to be less than 1. So I have an interval from -1 to 1. Check the endpoints. If x equals -1, I get the summation as n goes from 1 to infinity of -1 to the n times -1 to the n. These guys are going to cancel. so it'll just be 1 to the n, over the cube root of n. Now, p's not big enough. P's only 1/3, so this is going to diverge. If x equals +1, I get -1 to the n on top. 1 to the n, if I plug it in for x, is 1. And on the bottom, I have the cube root of n. Well, now my p is 1/3, but because it's alternating, it just has to be positive. So this will converge. And so my interval of convergence is from -1, not inclusive, including the 1. My radius of convergence is 1. D, what do I have? Okay, I've got the summation as n goes from 1 to infinity of x to the 2n, oh that's tricky, over n factorial. Right, okay. So I want the limit as n goes to infinity. I have x to the 2 times n plus 1 over n plus 1 factorial. Multiplied by the reciprocal, I have n factorial over x to the 2n. N factorial on top, n plus 1 factorial, they'll cancel and I'm left with an n plus 1 on the bottom. X to the 2n plus 1, this is 2n plus 2. X to the 2n, so I'm left with x squared on top. X squared over n plus 1. Oh crap, I left off my... I still have an n in there, so I need to leave the limit in here. Well, as n goes to infinity, x squared over n plus 1 goes to 0, which is always less than 1. So my interval of convergence is -infinity to infinity. I don't know if we actually talk about the radius of convergence. That's kind of weird, but it would be infinity, the whole line. E, what is E? Is it messy? Let's see. I have the summation as n goes from 1 to infinity of n over 2 to the n squared plus 1, lordy, all this stuff, x to the n. Okay, so I have the limit as n goes to infinity. Do all this, but replace the n's with n plus 1. So I have n plus 1. Go ahead and put this x on the top line. X to the n plus 1 over 2n plus 1, 2 to the n plus 1 times n plus 1 squared plus 1. Ah, that's a lot of stuff. Okay, so now reflipped. On the bottom, I have n x to the n. On top, I have 2 to the n times n squared plus 1. Polynomials. I've got an n squared here and an n squared. Let me rewrite this one. That might be better to rewrite this one to see it. So I'm going to just kind of match up the ones that I can cancel with. So I have n plus 1 over n, getting these two things, times n squared plus 1 over n plus 1 squared plus 1, getting these guys together, 2 to the n over 2 to the n plus 1, x to the n plus 1 over x to the n. So what's happening here? N plus 1 over n goes to 1. N squared plus 1 over n plus 1 quantity squared goes to 1. 2 to the n over 2 to the n plus 1, the n's cancel and I'm left with a 2 on the bottom. The x's cancel, I'm left with an x on the top. So what survives all this crap? We have an x over 2, and that must be less than 1. Ooh, I don't know if I can get all this in here. X over 2 is less than 1, which means my interval of convergence so far, I know that x has to be between 2 and -2. So let's plug these endpoints in and see what happens. if x equals -2, I have the summation as n goes from 1 to infinity of n times -2 to the n over 2 to the n times n squared plus 1. This becomes -1 to the n, 2 to the n, which the 2's will cancel. So I'm trying to cram this in here. Here I'm just left with the -1 to the n times an n over n squared plus 1. So it's alternating. My p is equal to 1, so this will converge. Oh, I'm sorry, I'm cramming this all in here. Not enough to rewrite it, but I am sorry. The summation as n goes from 1 to infinity. If I plug a 2 in there, I get n times 2 to the n over 2 to the n squared plus 1. These guys cancel. I'm left with n over n squared plus 1. It's not alternating. My p is equal to 1. So this will diverge. So my interval of convergence is I can include the -2 but not the +2, and my radius of convergence is equal to 2. F. Where's F? I have the summation as n goes from 1 to infinity of -1 to the n minus 1 over n times 5 to the n times x to the n. Okay. Ratio test. Limit as n goes to infinity. I have on top x to the n plus 1 over n plus 1 times 5 to the n plus 1. Multiply by the reciprocal, I get n. 5 multiplied by the reciprocal of a sub n. On the bottom, I've got x to the n. N over n plus 1, that limit goes to 1, so I can ignore it. 5 to the n over 5 to the n plus 1, I'm left with a 5 on bottom. X to the n plus 1 over x to the n, I'm left with an x on top. So I have absolute value of x over 5, and that must be less than 1, which means my x is between 5 and -5. If I plug in -5, I'll have the summation of -1 to the n minus 1, -5 to the n, all over n times 5 to the n. Now what's happening here? These are going to still cancel. Even though one's n minus 1 and one's n, the difference is I'm going to have a -1 on top. But that's livable. I have -1 to the n minus 1, -1 to the n times 5 to the n over n 5 to the n. What a mess. Those cancel. -1 over n. 1 over n diverges because it's your p is equal to 1, not big enough. If x is equal to +5, -1 to the n minus 1, 5 to the n over n times 5 to the n, they cancel. I'm left, it's alternating, it's 1 over n, so this will converge because it's alternating. So my interval of convergence is -5. I don't include it. I do have my 5, and the radius of convergence is 5. Three more to go. Now these get a little bit funky. These are actually shifted. All these other ones were centered at 0. Now this one's going to be centered at 2. What do I mean by that? The interval will be centered at 2. So if the limit as n goes to infinity, I have x plus, no I don't, I've got x minus 2, let's try this again, x minus 2 to the n plus 1. over n plus 1 quantity squared plus 1 times the reciprocal of a sub n. I have, oops, don't do it, be weird. I have n squared plus 1 over x minus 2 to the n. These polynomials, that limit is 1. The only thing that survives is the absolute value of x minus 2, which must be less than 1. So x minus 2 is between negative 1 and 1, which means x is between 3, and adding 2 to that, I get a positive 1. See how now the interval is shifted? It's centered at 2 instead of 0. Check my endpoints. I have x equals 1. This gives me the summation as n goes from 1 to infinity. 1 minus 2 is negative 1. Negative 1 to the n over n squared plus 1. I don't care that it's alternating. My p is equal to 2, so this converges. If x equals 3, 3 minus 2 is 1. I've got 1 to the n on top, which is just 1, over n squared plus 1. So this also converges because my p is equal to 2. So my interval of convergence is 1 less than or equal to x less than or equal to 3. My radius of convergence is, let's see, I go from 1 to is 1. Because I'm looking at the distance between 1 and 3 is 2. Half of that is 1. It's just like with a circle, you take half of it. 2 more. H. Summation as n goes from 1 to infinity of x minus 2 to the n. I did the same thing twice. Well, then that one's going to be easy to do. It's already done. I have the summation as n goes from 1 to infinity of x plus 2 to the n over 2 to the n times the natural log of n. What the hey? Okay, so let's try this. We've got the limit as n goes to infinity. I have x plus 2 to the n plus 1 over 2 to the n plus 1 times the natural log of n plus 1 times 2 to the n natural log of n over x plus 2 to the n. I need to figure out what this does. Okay, so I've got 2 to the n over 2 to the n plus 1. This will cancel. I'm left with a 2 on bottom. These cancel. I'm left with an x plus 2 on top. What the heck is this? I've got the limit as n goes to infinity of the natural log of n over the natural log of n plus 1. My guess is this should be a 1, right? Because they're going to grow at the same rate. But let's double check this. I've got infinity on the top, infinity on the bottom, L'Hopitaling it. Derivative of the top is 1 over n. The derivative of the bottom is 1 over n plus 1. Let's fix this weird-ass fraction. I have n plus 1 on top, n on bottom. Leading coefficient is 1 on both of these. The degrees are the same, so this equals 1. Well, that's convenient. This is equal to the absolute value of x plus 2 over 2. So this has to be less than 1, which means I have x plus 2 is between negative 2 and 2. Simplifying for x, I subtract 2 from across the board, and I get that. So if I plug in x equals negative 4, I get the summation as n goes from 1 to infinity. Negative 4 into my original here. I get negative 2 to the n over, where is it? 2 to the n natural log of n. Simplifying, remember this is going to be negative 1 to the n, 2 to the n. I'm left with negative 1 to the n. The 2 to the n's cancel, and I'm over natural log of n. Now, it's alternating. Natural log of n, since natural log of n is increasing, 1 over natural log is decreasing. So this is going to converge. That alternatingness is enough. No, the natural log on the bottom is enough to get us through let's just cut this part out. Having it alternating means the natural log, 1 over natural log, gets to 0 slow enough, fast enough. If x equals 0, I have summation as n goes from 1 to infinity. I have 2 to the n over 2 to the n natural log of n. Those guys cancel, so I'm left with 1 over natural log of n. That is going to diverge because 1 over natural log of n does not go to 0 fast enough. So my interval of convergence is equal to -4 to 0. I can include the 4 but not the 0. The radius of convergence is equal to 2. Sorry about the screw up. That actually might get cut before you see it, but you'll still see the picture. I hope that helps, and I hope you watch the ones that you don't understand.